Good morning. Welcome to our webinar on SQL Server and how to improve interoperability with FME. Sorry. Good. So let's get started. What are we going to be doing today? We've got Mark Stokes here, who is our Manager of Professional Services.
And we've got Robin Reddy, who's our Desktop Support Manager.
And so welcome, and let's hope we can show you some interesting tips and tricks of using FME with Microsoft SQL Server.
We've also got with us Steve McCabe. He's sitting around waiting to answer any questions you might have as we go through the webinar. So do fire up questions. He's one of our professional support specialists, specializing in all things database, actually.
Yes,
Steve.
Yeah, so Steve's a great assistance to us because we get many questions that are database-related questions. The way you can answer a question is in your little GoToWebinar dialog box there. There should be one of the boxes that has questions, and if you open it up, you can enter a question in there, and then Steve will be able to respond to you. And if you don't get to your if we don't get to your question during the webinar, we'll be sending you a follow-up email with any answers. We'll be also sending you follow-up. We record these sessions, and then we also put all the workspaces together, and we'll send those to you at the end also. So, FME.
This webinar is about FME. It's really a bit of a follow-up to the previous webinar we had on PostGIS. It's not an introductory webinar, so if you are new to FME, some of the actual details of the FME stuff may go over your head, but the concepts should be pretty clear of what we're covering and how we're working with SQL Server. FME's goal in life is to help you move data between a wide variety of formats. At Safe Software here, we started out in the CAD GIS arena, added database supports, particularly spatial databases, and over time we've added a lot of different formats from very different spatial contexts. Raster data, 3D and BIM data, more recently point cloud or LiDAR data sets, and even more recently we've been focusing on kind of cloud data sets like OData, and also doing a bit more work around support for the non-spatial data sets that we support, like CSV, text files, and even XML. This release, in the FME 2013 release, we cracked the 300 mark on the format support.
Mm-hmm.
The core part of the FME desktop application, which is what we're going to be looking at mostly today, is the FME workbench, where you author what we call workspaces, which are the workflows that define how you move your data from A to B.
So to get started, we'd just like to know a little bit about our audience. So I'm just going to launch a poll asking you what is your level of expertise. And this helps us to just figure out how to what level to talk here. So we've got a couple of questions here, and if we could get you to answer those questions, and I will close it in a few minutes, and we can take a look at the responses. Okay, it looks like we've got quite a lot of novice and intermediate users today, along with our regular set of experts who seem to always sign on just to see if they can get some little tip or trick out of our webinars.
So novice users of FME jumping 2 feet into using SQL Server Spatial.
That's right. So can I share that poll? Yes. Here we go. So this is the kind of makeup of our audience for today. Okay, so moving on. As Mark mentioned, this is not a beginner webinar. So if you are a pure beginner and you do find by the end of this that you're just completely bamboozled as to what's going on, we have a variety of options that are available to help you get going. And on that Getting Started page, there's some wonderful resources. There's a weekly webinar that we do where we'll answer some of your questions. We have free training do-it-yourself on-demand training. There's a bunch of tutorials and a whole lot of little recorded webinars or demos or short bits and pieces to get you started. So make sure you go to that page. It's actually right a button on the very home page of our website. So it's not hard to find the Get Started page.
Oh, another poll already. We've got to make sure the audience is awake this morning.
That's right. So what we want to know is what kind of issues you might have when you're working with your databases. So the kinds of things that you run into.
So what have we got there? Need to know SQL.
Server.
You use it a lot. Need to create intermediary files when moving data. Need to spend working through DBA. And need to create a new workflow for every database scenario.
Yeah. So you can pick any or all of these things. So these are fairly typical issues that you run into when you're working with databases, and this is actually exactly the sort of thing that we can get FME to help you with. Okay, I'm going to just close that and I'll share it with you. So need to create a workflow for every scenario seems to be the most popular one. So
a lot of people using SQL calls and creating SQL scripts, I guess.
Yeah. Okay. So FME, the version of FME that we're going to be working with today is FME 2013 Service Pack 1. We're also going to be working with SQL Server 2012 because FME 2013 had a whole lot of new support added so that we could work with the new geometries that were available in SQL Server 2012. And so the kind of license that you need to work with this level of database is the FME SQL Server Edition. So we have a variety of licensing levels, and the base professional level in the middle here is the one that's sort of most common for your CAD to GIS back and forth. But if you're working with spatial data sitting in an enterprise level database, then you're going to need the higher level database edition.
And you get everything inside it. So as you move out the circle, the licensing moves from the inside to the outside in terms of sophistication and the formats it supports. You get all the formats on the earlier editions. So if you get the FME SQL Server edition, you would also be able to read and write as read your databases as well, as an example.
Oh, and this is just about our last poll. So we just wanted to keep you involved, but what we're looking for here is just some general information on how people are using SQL Server. And so first up, have you upgraded to SQL Server 2012 yet? What has sort of been the take-up of that? How many of you are using the geometry storage type as opposed to the geography storage type? And these kind of things are fairly specific to SQL Server. And then how many of you are using ArcGIS Desktop to access your SQL Server database as a pure SQL Server database, as opposed to using GeoDatabase sitting on top of SQL Server? So
or SDE, I guess.
Yeah, or SDE. So just, how many have migrated towards the newer ArcGIS so that you can hit your SQL Server without all that complexity? So it looks like quite a lot of people are using ArcGIS Desktop. And the geometry storage type seems to be one of the most popular.
Okay, so let's share that.
Yep, I'll close that one up and share those results with you. And so you can see that this move towards using straight databases from ArcGIS Desktop is taking off.
So most people are using geometry rather than geography, so that's interesting.
Mm-hmm.
And quite a few people connecting direct to SQL Server. That's interesting.
And some take up on the new SQL Server 2012. I don't imagine it's simple to upgrade from SQL Server 2008 to 2012.
Yep.
It's easy for us. We just put down a brand new version.
Okay.
Cool. So let's get on to the good stuff.
All right. So the agenda today is a bunch of demos that we're going to give you on, and hopefully tips and tricks on using SQL Server. Around the SQL Server functionality in our readers and writers, look at some of the database transformers that also allow you to access SQL Server, some change detection examples, And we've also got a geometry validation example as well to try and help you know whether your data is going to load successfully, particularly into the geography.
Yeah, well, both of them. What we decided to do with this webinar was, rather than sort of dragging out our regular sort of workspaces, is we've gone off into a little bit of the more specialized stuff. So as I said, it's not a beginner webinar. So we're going to look at some of the functionality that's fairly specific to SQL Server, and then some of the more complex transformers that you do tend to use if you are working with databases.
And just a reminder that the webinar is recorded, so it'll be put up on the website, and all the materials and the workspaces that we're using here will also be available to you to download.
And that goes up pretty quickly. It should be there by tomorrow or the next day.
Yep. So some warp speed demos. So any of you who have been watching the world tour that we've just wrapped up in North America will know that the Zipster is the mascot for the world tour this year. So and that's around being able to access zip files in FME now. I think you've got a demo of that as well.
Yeah, now I've stopped unzipping packages when people send them to me, because I can just now read them right from within the zipped file. It's a great piece of functionality.
Okay, so let's have a look at writing some data to SQL Server. We're going to have a look at an example of loading data. And in this example, what I have is another database. I'm going to be using this small world database as the source of the data. And that has multiple spatial columns on the data. And we're going to load those multiple spatial columns into SQL Server. And then we're going to look at some tools that you can use if you need to create more complex tables than FME natively can support. And then we're going to have a look at some incremental updates and how that can work. So sort of around the idea of database replication across from one database to another. So let's bring up FME Workbench. That's not the workspace we're going to start with. And let's have a look at the starting workspace I have here. So the data set...
Can we zoom in a bit, Mark, so we can take a look at...
Zoom in a little bit here.
We've got a new slider zoom bar at the top that you can use.
That's right. Okay, so the source data I'm starting with is actually coming from a small world database. I'm not sure whether many of you are familiar with that. And what we're looking at is a very simple electrical network in that small database. So here's the electrical network, and it's got some customers and supply points on that network. And the small world database inherently supports multiple spatial columns. And so if we're going to load a SQL Server database with multiple spatial columns, how do we do that? So the first thing we would do here in FME, our sort of native SQL Server writer can't create more complex tables that include multiple spatial columns. So in this case here, what I'm using is a transformer called the SQL executor, which allows us to throw pretty well any SQL command at the database. And in this case, the SQL command that we're going to be using is the create table, where we can create the multiple spatial columns. So here are the two spatial columns that we're going to create in that SQL Server table, the location and label for the electricity supply points and so on. And a bit of scripting as well to test whether that table already exists, so that we don't get errors along the way. So you can pretty well throw any SQL at the database that your database supports. And the interesting thing in this case is no data is returned. So we're not doing a select or anything. We're just firing off a create table.
Yeah, so what are all those things in the over there on the left-hand side where it talks about SQL spatial functions and SQL aggregate functions and stuff like that?
So we have put in tools there. So here's the list of the database table. So as you're building up your SQL select, we'll have a look at another example of this. You can pull on the tables, have a look, drag on the attributes within the table. And then we've also thrown in all the various SQL commands that you can use and functions that you can drag on there to add to your SQL Select.
And if you don't know how to use them, there's actually a direct link in there to the actual help for those SQL statements. So that takes you right to the Microsoft help for those various SQL commands and functions.
Yeah. Okay. So when we run this workspace, the creator transformer makes sure that this happens first. There is also another sort of sister transformer for the SQL executor, which I could have used here. It's called the SQL creator, and that guarantees that the SQL is the first being executed before any data is read from the database. Okay, and so looking at some of the example data, let's go down to, I think it's the substations. So when we're working with multiple spatial columns in FME, we do have to sort of tell FME what we're doing. And the reason for that is that FME kind of stores a multiple spatial geometry in a similar way to we store an aggregate feature. So we have to tell the aggregate that it's actually being treated as a multiple geometry rather than a multi-part geometry. And so we have a special transformer here, the multiple geometry setter. And as we read in the data from, in this case, small world, it's got multiple spatial columns on it. We're just telling FME that this data is not just a pure aggregate multi-part geometry, but is actually a multiple geometry. So that's all that does. It just says, yes, we're containing multiple geometries, multi-spatial fields. And then what we have is some properties on the geometry where we can name the spatial column. So as we write this out to the SQL Server database, and I've got an annotation and a location column on this entity, on this feature, then we need to tell FME what those geometries, what spatial columns those geometries attach to. So the geometry property setter is a transformer that allows us to do that. So in this case here, we're telling it that this particular geometry is the location, and in this case here, we've got another one that is the annotation geometry. And then we can write those out to, in this case, the substation.
Don't you have to do a setting on the writer to tell it to handle the fact that it's multiple columns?
So also on the writer here, we have to warn it that these special geometries are coming, and that's what that parameter there is, handle multiple spatial columns, is set to yes. So FME knows that it's got to look for these particular kind of aggregates, which are aggregates that have been told that they're multiple spatial objects, and that these geometries will have a geometry name on them which tells us what column that's going into. So if we look at one of those tables in our SQL Server database, I've already created them ahead of time, we can see that we've got those two geometry columns there, the location and the label.
And there was something important about the order of those columns too, wasn't there, right?
Yep, because if you just are using the default behavior of FME, you can just read one of the geometry columns at a time. And the default behavior of FME, well, if you're just starting to read, and we are going to look at some read examples in a little bit, FME will just read the first geometry column unless you tell it something else. So having the location first means that the locations will be the columns that FME by default reads rather than the annotations or the labels.
Cool.
Okay, so we could just run this workspace with prompt and run, and we would, I've got the database tables set up so that they won't drop the table, but one of the parameters I had there on my prompt and run was to truncate the tables first, and so that will set all the parameters on the feature types to say, yeah, drop the features from the table and reload them.
The other thing you could have prompted for there was possibly your password too, rather than hard coding a password into your workspace.
Yeah, I'm using, in this case, I'm using Windows authentication, so I don't need to do that.
Oh, excellent.
Yeah. But yeah, any of the parameters that you want to set and have the user set when they run the workspace, we can do that.
So it looks like your translation was successful.
Yep, and so we've got some data sitting there in our SQL Server. Okay, so then I'm just going to open up a second workspace, which is essentially the same one. It's got slightly different parameters set. So it's this guy here. And one of the things about Small World, which is a nice feature of the Small World Reader, is that it returns back differences from the database. So they have a versioning mechanism they call the alternatives in Small World. And so in this workspace, which is the same as the previous one with these parameters just set, I've told it that I'm reading from the FME alternative. I want to compare that with the baseline alternative, which is the top alternative. And then I've set the writer mode to be update here. And so let's just have a look at what how that works. So instead of writing at this point to the SQL Server database, I'm just going to write to the data inspector so we can have a quick look at the intermediate results and see what FME is doing when we do these incremental updates. So here you can see is a partial set of the data, which are the update features that have been recently added to that database. And we've got cables, joints, and supply points that have been updated. If I click on one of these features here, we can see that the Small World Reader has automatically added an attribute called the FME DB operation. And when you're trying to do incremental updates into a database, actually all of our databases support this mechanism. If you set this attribute, the FME DB operation, then FME will do these commands. And so the three values for FME DB operation are insert, modify, or delete. Update or delete. And I think we do have some deletes in here. So there's a delete that has been returned from the differences in the small database. I know there are some updates in here, but I couldn't find any when I was poking around in here earlier on. But anyway, there are some updates, but these ones are inserts.
But it's only the Small World that will give these to you automatically, right? So generally your data isn't as well organized as this. So
yeah, and that's always a problem when you're doing incremental updates. So typically when you're in the database realm, if you're doing database replication, you might have a history table or some kind of a journal table which is tracking those changes. That's a really useful mechanism. I don't know what the equivalent product is now, but Esri used to have a product called JTX, which tracked all the changes in the database that we used to support. So basically, if you can read a history table, you can figure out what those changes are, and then you can set the FME DB operation.
And is it...
Go ahead.
Okay, and there is also a transformer called our change detector transformer that can sometimes be used to figure out differences between two sets of data too. But all of these are ways of getting the data so that you can flag it as to whether or not it's an insert, an update, or a delete.
Okay, and so if we were to run that workspace now, and I redirect those, instead of redirecting to the inspector, I just send it right off to the writer, then I guess I could bring up in the data inspector a view of the data as it exists now.
So somebody was asking, how do you connect to your database? So this is actually the dialogue you use in both the readers and the writers to connect to your database. And so the kinds of things it's looking for are the server name, And so here on our machine, we're using a SQL Express edition, but if it was a named SQL instance, you could have put that in there. And again, Mark mentioned he's using Windows authentication, so there's no prompt here for user or password, but if he turned that off, it would ask for a user and a password. And so that's all that's required to connect to your database. And once you've done that, you're given the option of picking the tables out of that table list. So we go out and read the list of tables that are in that database, present them to you, and then you can pick the ones you want to read to. And that's standard across all our database formats. The dialog for connecting is in the readers and the writers, and then any of the database transformers. And it's sort of a common dialog through the whole lot of them.
And so this is the area that we're going to do those updates to. So if I run that workspace, those few features that are detected as being changed in the core small world database will be sent over to our SQL Server. And I think if I refresh here, you can see those new features have popped up down at the bottom, were inserted, and some scattered around here somewhere, some deletions.
Okay, so you're using the data inspector here, Mark, and so this is been improved so much in FME 2013 that I would encourage anybody to take a look at it. And what's the big reason for that big push into the data inspector? The table viewer. This is my favorite part of pretty much 2013, is the fact that now when you're working with databases, we can actually look at the data as a real table as opposed to a funny little feature information window on the side. So you'll notice Mark is flicking between the different tables of the different feature classes that he's looking at. We can actually sort that data into different orders. If you want it sorted by ID, you can sort by ID, etc. And so this has really taken our viewing tool into the next generation. And so give it a try. It's an option up under the view at the top. So if you click on the view, one of the options under the windows is to pull up the table viewer.
Yeah. Right now it's not the default visualizer, and of course if you're new to FME, you're probably wondering what the big deal is all about. If you're an existing FME user, you will
have watched us slowly bring the data inspector in and wondered why were we bothering.
And what's so great about a table view.
Exactly, but now it's in there, and this is the way you can set it as your default, is in your FME options under the tools menu, and turn that on and try it out. It's still got a few things that aren't quite there compared to the universal viewer, but personally I find for working with databases that it's now my default application. One more thing before you close that down, Mark, wasn't there something I had to do on the writer to tell it that I was passing through these FME DB operation
No, we already
options?
looked at that.
Did you look at that already?
Yeah, that was the handle multiple spatial columns.
No, it was the writer mode. Just down underneath that we have a writer mode.
Yeah.
That's telling it that we want to do updates to our data as opposed to just straight inserts. And so that fact that that's set to update mode and that DB operation is coming through on those features tells the writer to act on that FME DB operation. And there's one more thing on each of the feature classes. You have to give it a field that it's going to do the matching on. And so under the format attributes there, we have a SQL key column where we tell it, when the feature arrives, check and see if the IDs match, then act on the FME DB operation. So it'll either do an insert, but if it's a delete, it goes and looks for the matching ID and then deletes the record.
Yeah. Okay. So some tips and tricks on writing to databases.
Yeah, so this is sort of the usual standard stuff. Use a unique key field as much as possible. Databases like unique key fields. If Mark can open up one of his workspaces that's actually reading from a SQL Server table, we've now added the ability to index that key field in the writer. So one of the options on a writer, if you go back to that workspace you were just in and open those up and look at the user attributes, you'll notice that the index there has got a whole lot of new options on it. So not only can you set a primary key, but you can also set clustered not null or unique not index not null, etc.
That's only happening if you're creating the table.
Creating the table, yes.
Then, yeah.
In Mark's case, where he'd already created the tables, none of that would take any effect. Stay there for a minute. So another new option in FME 2013 with SQL Server was the bulk insert. So over on the navigator pane, bulk insert has the option of being set to yes or no. And this allows you to write, it's a different method of writing. So instead of writing one record at a time, it stores them all up and then bulk copies them into your database.
And it is only for inserting, not for incremental updates.
That's right. You'll see that there would have been a warning in Mark's log file saying that because you had update mode on, it was going to ignore the bulk insert. So we don't mind it being set to yes, but we will ignore it if you're in the update mode. What we've found with that bulk insert is that if you're writing to SQL Azure, so the cloud formats, it makes a huge difference to performance, anywhere from 10 times faster if you're using that bulk insert mode. So also in sort of that kind of area is the transactioning. We have transactioning on all our database writers, and so the one for SQL Server, we set a transaction amount by default to about 500 features, and what that means is that we won't do a commit until after those 500 features have been written to the database. That bulk insert also takes notice of that transaction interval, so it's going to work on 500 feature clusters and copy them into the database in that kind of volume. If you're worried about committing and rolling back, there's a couple of things you can do. You can set your transaction interval down to 1, and that means that we will commit on every feature, so that then if you run into a feature that won't go in, it'll just roll back that one feature. However, if you're looking to do a commit or a rollback of the entire process, then we set that transaction interval to a very large number so that we commit at the end of the entire process. A couple of other things to be aware of with that is that that commit block is only around the writer. So if you are trying to do a bit of fancy stuff in a SQL executor and you're actually modifying the database in there and then doing stuff in a writer, that's 2 different transactions. If you want to be able to manage your transactions with rollbacks, you need to be doing everything in the writer. So along with that comes some performance stuff. Most of you are database gurus, so this is pretty standard stuff, but make the database do the work. We've got a number of transformers that can work with databases, but if you can do where clauses on your readers or spatial envelopes on your readers to reduce down the amount of data that you're bringing into the workspace.
Or joins, you can add joins and selects in the reader or through SQL executors.
Yes, all of that makes the database do the work where it's optimized, in its native environment for doing that kind of stuff. Indexes, attribute indexing is now available, so you can index all those attributes. And in FME 2013, with SQL Server 2012, we can help you build a spatial index. It used to be very difficult with SQL Server 2008. Actually, can you bring back your workspace, Mark, and I'll show the option on that writer. There's a new format parameter on the writer over here on the destination dataset, because of course it's set on each particular destination dataset. So here we have a spatial index type, and you can ask for none or do it manually. If you decide you want to manually create the index, it opens up a SQL text box here that you can put your SQL statement into. If you're working with SQL Server 2008, this is how you need to do it still. Either do it manually or say that you aren't going to build an index. For SQL Server 2012, you can ask us to automatically build the index and then provide it with a bounding box that it can use to make that index out of. So if you're building the table, as opposed to how Mark did it by pre-building them, all that capability is available in your writer. Cool, and again, the bulk inset mode is fast. So let's take a look at some database transformers. Although we promised you wouldn't have to use a lot of SQL, the very first one we're going to look at is the SQL creator or the SQL executor, because people from the database world are SQL experts, and their SQL is often very efficient. So we'll show you some ways of getting that in.
Okay, so let's, no, I don't want to save that, and we're going to go to SQL executor example with joins. So this is just an example, again, of just firing a query at a database and returning some results. So I'm using a created transformer just to create a feature out of the blue, has basically no content, but it triggers the execution of the SQL statement. And then here's the SQL statement here. So it's just a simple select with a join on it. And so we're joining together the customer data table and the electricity supply point table and outputting those as results. And so that's a good example of getting the database to do the work. If you can do joins in the database, then that's what we'd suggest you do. And just popping those results up in the data inspector instead of writing them to a particular format. But you can see here we're bringing back the address, the name, and attaching that to the supply point data. So that's a really simple example of using SQL Executor, and as we had pointed out before, a lot of the tools that you can use in here for selecting database tables, selecting attributes from those tables, and using different SQL functions are all in the Browse tool here. And we've got another little SQL executor, number 3. Is that?
Yep. Sure. So that was one fairly simplistic use of SQL, the SQL executor. But we discovered another good use for the SQL executor in that often you're presented with a file that looks something like this, where you've been given a whole lot of SQL to read into somehow and load up your SQL database. And nobody kind of figured out how you could do this with FME, and one of the guys here in professional services realized that you could actually use the SQL, the text line reader, to read this file, one file at a time, and the SQL executor now can act on each one of those lines one at a time as they come into the executor.
And I think that's kind of equivalent to a SQL loader, which is probably more common in Oracle, but yeah, so it's equivalent to a SQL loader tool.
That's right, and we didn't have the ability to read SQL loader, the SQL loader format, and then finally figured out we could do it this way. So in my case, I'm actually going to create a table, and one of the columns in my table is going to be an identity column. So I'm going to create the table with an identity column and then populate it with a whole bunch of points here. And I'm also going to drop a couple of tables first, because if anyone was watching closely, they'll have noticed that they already exist in the database. So my workspace is here. So it's doing a text line read. The SQL executor is set up to point to the correct database. And what I'm doing in my SQL statement is just reading the value out of each line of the input data and going to act on it. And so when I do that, you'll notice there won't be anything coming out of here because it's not actually producing anything out of the select statement. It's just going to run it and write the tables for me. So if I take a look over here in my SQL Server Management Studio, just refresh this, I should have a customers table here that's got some records in it. And sure enough, it's used the identity field, the ID field, and added a whole bunch of records into it and produced me some point data. So that's handy, but then they went and gave me some more information. I'm just going to turn that little bookmark off and turn this one on. So now they've given me some more information, and it's sitting in a CSV file. So this is a different format to the one that I originally got. Now I've just got a CSV file with a whole bunch of different coffee shops and lat long. We're in Vancouver, it has to be coffee shops, and lat long points of where these customers might be that drink from these various coffee shops. But no ID field, and sort of I could let that identity field increment itself, but I'm going to go and find what the value of that last identity field is with using a SQL executor. So here I'm going to read from my CSV file. I'm going to spin off the very first record from that CSV file and point it through to a SQL executor that's going to go find for me the last used identity number and then increment it and provide that to me as the next value that I need. It's sometimes useful to be able to manage that field by yourself as opposed to letting the database use it. Perhaps you need to set up a cross-reference table that's got these identity columns in it so you can make use of that value. And you can do that by using the SQL executor.
So this is like a sequence number.
That's right. So it's similar, very similar, or exactly the same as working with a sequence number in Oracle or a serial number in PostGIS. They've each got their automatic incrementer data types. Once I've got that next value, I'm going to set it into a variable because I want to save that value and use it as the starting point for my counter down here. And so the way to get my next value from my SQL executor and onto each of the features as they come through is by using a variable. So here is my variable setter, which is just going to take that next value and store it into a variable. And my variable retriever here is going to retrieve that value and use it to start up my counter. So once I've done that, convert all my points into 2D points, count them up, and write them up into my database. And so you'll notice here that I actually have the ID field here, and there's a setting on my writer that says I want to insert into the identity column. So I have an option here to turn this on or off based on what I'm trying to do in the workspace. So if I look at my counter here, I just incremented them again by another 10 just so that I could tell what that it actually had worked, because it got a bit confusing otherwise. So let's just run this. And if we go take a look at it in our SQL Server, just refresh our tables, rerun our script. And if we open up the ID field here, we should see that our last bunch of records have got coffee types in them, and the identity field got incremented the way I wanted it to be incremented. So it left a space at 10 and started to put the new records in. Okay, so that's another use of the SQL executor for getting at some of those system values that you might want to use within your workspace.
So other database transformers that we have in FME, if you're not a SQL person, the joiner is a great transformer. We're not going to look at it in detail today, but you can experiment with that. It doesn't require any SQL knowledge. It just allows you to do a very simple join based on multiple attributes to a database. It's a non-spatial tool, so it's basically there to help you join together non-spatial data, usually to some spatial data, in a similar way that I was joining the customer table to the supply points earlier on. The feature merger is an in-memory join tool, so in some ways very similar to the joiner, except you read all the data with a conventional FME reader and then do the joins in memory, and again doesn't require any SQL. We do have the inline query, which we're not talking about today, has kind of a very different role really in merging data together, so there are separate articles on the inline query.
Yeah, and sometimes you need to do testing to see which of these is the most efficient in your environment, because it really comes down to how many times are you going to go out with the joiner and hit the database versus how many records do I need to read into memory to merge them together. Mm-hmm. So we always sort of recommend doing some testing, bulk testing as to which of those is the better for you.
Yeah, the joiner has some caching, and so it's very effective at doing lookup table kind of joins. So if you have many features where you want to look up domain or enumerated list kind of values, the joiner is really efficient at doing that. Feature merger is generally better where you're doing joins and merging data of similar numbers of features, where the requester and supplier features, as we call them, are kind of more or less similar numbers.
That's right.
And then the feature reader is an interesting transformer, allows us to throw spatial queries back to a database. So let's go and have a look at an example of the feature reader in use. So what I'm doing here is I've got a SQL Server reader where I'm reading some road data. Then I'm going to buffer that data by a certain amount, dissolve the buffer together, And then what I want to do is I want to do a spatial query on some of the data in my SQL Server database based on any features that fall inside that buffer. In my SQL Server reader here, I've set up a simple where clause, so I'm just bringing in just the road, the Oak Tree Avenue road, which is where the new data that we put into the updated data that we put into that database earlier on. And then the feature reader has it's kind of a wizard, has quite a few parameters on, connecting to the database itself, and then what kind of query do we want to do. So I'm giving it a list of tables in an attribute. In this case, I'm just looking at the supply points. We could throw in here a where clause. And here's the interesting part. So this is where we can tell the database to do the work. So we're going to throw a spatial query back at the database, and we're going to use a contains predicate to say if any of these buffers contain some of these features, which are the supply points, return those features. A few more parameters to fill out there. And so if we run this thing, I'm also reading some background data just so that we can get some context here. I'm going to zoom in down here. And so let's just start looking at the data bit by bit. So here's the road information that we've got. Maybe we'll make those a little brighter. And one of these roads is the road that we're interested in, I guess, the Oak Tree Avenue. So that's the one that we're getting query from. Not got the buffer there, so this is the buffer showing up that we buffered around that point. And then here are all the electricity supply points in our spatial database, and the feature reader is returning only these ones here. Let's make those a bit brighter as well. Okay, so it's just returning those supply points that fall inside the buffer. And again, that's the old philosophy. If you can get the database to do the work, fire off the spatial query back to the database using the feature reader, and the data that you, those queries will be a lot more efficient. Mm-hmm. The feature reader will actually work on non-queryable data sets as well. So you could do this query back to shape files, XML or GML files that are non-SQL databases, and in that case, the actual contains or the spatial predicate will be done in memory in FME. So it would read the entire data set. So you wouldn't get that performance gain, but it is still a very convenient way of doing spatial interactions.
I want to show you something new on the feature merger. Mark, if you open up the transformer over in the navigator pane there's a new setting on it that's just sort of come in the last release or so. So over there in the navigator pane, reader, yeah, on the feature reader, it now has a caching option. So it also can provide a cache.
Yes.
So down here, if you're working with a format like Mark just said, or if particularly you are going out to do feature reading from something like SQL Azure, you can enable that cache. And what we do is we write that the amount of data that you've pulled down, we put it on a temp file in the temp directory, and then the next time you run the workspace, we'll go and hit that cache instead of having to go out and connect to that cloud-based format a second time. So I wouldn't turn it on in general, but for the formats where it's very tedious to go and get the features, Salesforce Reader Writer or the cloud formats, enabling the cache on the feature reader can be an option for you too.
Okay, we've got to keep moving because
we're going to run out of time.
And the clock here is dead, so we're not tracking ourselves very well.
Okay, so we were going to show you a bit about the geometry validator because there's been a huge amount of work done on this transformer in FME 2013, and this is a transformer that's very useful when you're writing geometry to a database, because SQL Server in particular is quite happy to let us write anything into the database in terms of geometry, but the problem is we get it in there and the SQL Server itself doesn't like it. So it's a good idea to pass your features through the geometry validator first and see if it can repair them or fix them up at all. And so the new geometry validator has got a set of 12 tests available for you, and many of these tests actually will repair the features. So there's a repairable option on there that says, yes, fix up my 2D, my intersections in 2D, for example. There's also 2 tests there that are just testing to see whether your features are OGC simple or OGC valid. So those 2 tests actually don't allow for repairs, but most of the rest of the tests do. There's a button at the bottom to say, do you want to attempt the repair? And you can set that to yes or no. Consequently, the transformer's got 3 outputs, and so output will come out of the passed port, the failed port, or the repaired port. And it's very important to pick up data out of that repaired port when you're working with it, because that is your fixed data. And sometimes features are just unable to be fixed, so they will always come out of the failed port. Similarly, if you're testing for these OGC tests, these will always come out of the failed port. So in my example here, I was going to load up a shapefile of world boundaries. So if we go and take a look at the data, have you got a data inspector here? I can drag them into my data inspector and take a look at them. So this is an AS3 shapefile of data from all around the world. And you know, you can sort of guess, what countries are we going to have problems with? Russia, which you'll notice goes right from one end of the display to the other, and Antarctica. So there are a couple that could cause us some grief when we try and write these into our SQL Server Spatial. And in fact, in this case, and it took me a long time to figure this out, Antarctica is in so much trouble here that it actually has a minimum value that's below -90, which is means that it's fallen off the bottom of the world. So in my particular workspace, Antarctica will never get into my database because of that minimum value there. So I should have put a clipper in here to clip it before I tried to load it. What I did instead was found a cleaner set of data that's here, which I've included for when you get these workspaces, you can try this stuff out.
And that is using your Zipster.
Actually, let's go play with that. So this is opening, this one is using a zip file. So I didn't bother to unpack it. So if we go back to our data inspector and take a look at it, I can drag that zip file into here, and I just have to tell it actually what format it is, because it can't guess from the extension. But it's going to read the data right out of the zip file without me having to unzip it, which it does. And if we take a look at Antarctica in this particular example, you can see that those minimum values have been fixed. So this one would have gone in for me, but I preferred to play with the bad data. So as I processed this data, I had to, you know, it's complex data. It's got a lot of those countries have got incredible, if we go back to my data here and take a look at, say, Denmark up here, which is right here, and we go really far in, we've got some interesting overlapping stuff happening here. So we know that we're going to have an issue with our data because it's just not good enough quality. We'll certainly be able to read it into or write it into SQL Server, but SQL Server is going to complain once we've got it in there. So what I had to do was pass that data through some geometry validators to get it to be cleaned up. So I passed it through the first geometry validator, looking to do things with those self-intersections. And of course, once I've done one cleanup of it, and it's repaired a number of features, it may have actually created new self-intersections. And so I ended up having to run it through 2 of them to try and get the best output that I possibly could. And so if we take a look at this and run this workspace, you can see by the feature numbers. I just want to check that we're dropping the tables. Yep. And in fact, what I did here was I ran it through to 2 tables. One's the geometry table, using the geometry spatial type, and then the other one was the geography spatial type. So here I'm letting it inherit that spatial type from the writer, because the writer was set up by default to use the geography spatial type. And we can see that over here in the navigator pane. So one table is going to have geography spatial type with a geog column, and the other one will be a geometry spatial type. So let me run my workspace and we'll take a look at what happens. So I still have some countries that have got some problems, and interestingly enough, they turn out to be Italy and Norway and Indonesia and New Zealand. It's hard to believe New Zealand could have problems with its boundaries. But you'll notice how 54 features came out of that repaired port, and once I validated them again, it still repaired another 4 features. So if I go and take a look at my SQL Server in here, and I have a command that I can issue that asks whether or not that geometry has gone in and is it valid. And so when I do that, I can execute my statement. Oh, and we forgot to fix these table names up. So let's just, in the interest of time, we'll presume that it found a bunch of bad data. And in fact, if this new geog is valid detailed, will give you the message showing you what the error number was and the cause of the error. So you get some more information from within SQL Server as to why your geometry is bad. And so how to fix that automatically within our workspace, the last thing that we can do is actually use a SQL statement to execute after the translation's complete that allows us to update those things. So we can put our statements in here to fix that geometry by using the make valid function or process. Not being a SQL person, I don't know what the right word is, to clean up our data. And so running this workspace again would run this through correctly and fix our geometry in our tables. So it's just worth looking at the data, checking that it's okay, because we are very happy to write anything into your database, and the geometry validator will help clean your data up for you.
And I think we are planning to add the SQL Server is valid functionality into the geometry validator in the next round of development there.
Excellent, so, because so it will become.
So our goal is eventually you can choose which kind of validation options you want to check off here. You can do that manually or not. And our goal is to add a list of databases here. So validate for SQL Server, validate for Geodatabase, validate for Oracle would be nice to have in there eventually.
Yeah.
Selling off some vaporware there.
Mm-hmm. Cool. So we're just about out of time here. So what else do we have left?
Last one. So one of the widest uses for FME is still moving data between GIS and CAD. And so there are ways to do that. One couple of things that are always important about going out to CAD is trying to stylize your data. So we've got tools for doing that. And then the other one is often when you are moving data between GIS and CAD, you're doing a lot of schema readjustment, renaming attributes, merging feature types together, stylizing the data in some way. And so what we have are some tools to actually help you simplify the actual workspace. I'm not going to go into this in a lot of detail because there is quite a lot written particularly on FME Evangelist, has got a lot on dynamic workflows and schema mapping. Yep.
Yeah, and in fact, the Evangelist is exactly where I start every example where we have to use the schema mapper, because it's a complex transformer, but Mark Island has done a great job explaining it.
And so if you get into this kind of workflow, you can really simplify your workspace. One thing is here we're reading all the SQL Server tables that we want through a single feature type. So you don't have to have 10 or hundreds even of feature types in your workspace to deal with that. In this case here, we're de-aggregating to split up those multiple geometries that we have on this particular SQL Server database. And then here, what we have is the schema mapper, where we're looking at a table, and it's a spreadsheet, which tells us tells FME how to rename attributes, reset lookup tables, set AutoCAD colors and particular entities like that. And that is all done in a spreadsheet, which is referenced by the schema mapper, so that we can get a nice and good result out in the, in this case, AutoCAD that I'm writing to. The other interesting thing that we're using on this particular example is what we call a workspace resource. And that resource is another table that tells FME what the layers and should look like in the AutoCAD, and what attributes and the type of attributes that that AutoCAD table should or layer should have. So the schema mapper is a tool for doing bulk schema mapping, so you can externalize that mapping spreadsheet. Again, when we run this, this is dynamic, so we can choose any of the tables that we have in our database, and if they appear in our schema mapping spreadsheet, then we will do that mapping across. And that's just one idea on doing that fairly common task of CAD to GIS.
Okay, what else we got left? Because we're right out of time at this point.
That is wrapping it up.
Okay, so I just had a screenshot showing how you can access your SQL Server without having to worry about geodatabase or SDE or any of this kind of stuff. So here is my coffee shop customers and my various coffee shops, and someone said Tim Hortons. We gave ourselves away. We're obviously Canadian. So, so basically just connecting to the database using the new ArcGIS 10.1 database connection. These are my SQL Server tables, nothing special about them, just SQL Server geometries, and I could drag them right into my ArcMap and view them in there, add more data to them, etc.
You didn't need a special ID field?
I did need an ID field, and it did need to be a primary key, but in fact, if I don't have an identified ID field, when I drag it in, it asks me which of the attributes I want to use as an ID field, and it actually sticks its own ID field on there for you. So it's way more easy to use than ArcGIS 10.0 was.
Yeah, great.
So that's great. And then we're rapidly running out of time for any questions and answers, but the Steve's been extremely busy over there on the question and answer panel. So if you didn't get to one of your questions, then we will get back to you in the next few hours.
Did we have one sort of common question that kept on coming up? Or?
Nope.
Nope.
No, it was Steve's had his morning cut out for him. So thanks everybody for listening. If you've still got time to go to Australia, New Zealand or Europe, you can pick up on one of the last of the remaining World Tour meetings. I think there's even some in Spain and Brazil.
Yep.
And then we have a couple more webinars. In June, we're doing another one about Oracle, so we'll pick up on some of the Oracle specialities, possibly using triggers, and we could look at sequence numbers again. And then we've always got to publicize XML, so if you're interested in XML, there's one next week on reading and writing XML with FME.
All the webinars that we do are recorded. We try and put up there all the examples, the workspaces. So if you're starting a little project and it's similar to something we've shown here, grab one of those. It's always better to steal somebody's project as a starting point rather than working from scratch. So have a look at the recorded webinars. There's a lot of good stuff there.
And you'll get the workspaces as well. So one last poll question, just to see if you'd be interested in training opportunities. If you respond to the poll, then you'll get a follow-up email offering you the various dates for the training courses.
So now all of our online instructor-led training is complimentary, and so we really encourage you to do that. The FME desktop training is just 2 mornings. You get an AWS machine, an Amazon Web Services machine to do the hands-on exercises with an instructor. And then we also run some advanced courses. We just recently ran a SQL Server course, actually, didn't we?
Yeah, we did.
And so that's a little out of sync. Normally we run the course after the webinar. And so yeah, have a look at that schedule and sign up for training if you think it's going to help you.
Great. And I think that's it. Yep. So we'll be following up with you shortly with an email. But thanks very much for listening. And if you've got any more questions, sales, you can email sales. Support come in through our webpage, and then or contact Mark or myself personally. Great.
Or Steve, we should have.
Or Steve.
He's the one answering the questions.
I feel sorry for Steve.
Thanks a lot, Steve.
Thanks for doing that. So.
And thank you for attending our webinar this morning, and we'll see you at the next one, we hope.
Great. Bye for now.